This cross-section of soil mechanics shows exactly how aggregate stability fails. Synthetic NPK fertilizers are salts. When they dissolve, they actively break apart the porous physical structure of natural soil aggregates, collapsing them into a dense, compacted layer of dirt. That compaction triggers a catastrophic drop in water retention. When heavy rain hits, the water ends up pooling on the hard surface and running off horizontally, completely unable to percolate down to the root zone. Healthy, humus-rich soil maintains a highly porous structure, allowing it to act like a sponge that absorbs and holds massive amounts of water deep underground. Because the natural nutrient cycling microbiome is dead in chemically compacted dirt, the farmer now has to pay for and artificially apply 100% of the nutrition the plant consumes. This physical degradation is an economic death spiral. It guarantees that the farmer's input costs will escalate every single season. The first step in the biological transition protocol is redefining how we disrupt the soil. Historically, tillage was a shallow process, utilizing implements like oxen-driven wooden plow. Modern agricultural logic reverses this, driving heavy steel deep into the earth. This violently severs the subterranean fungal networks that crops rely on to transport water and nutrients. Ripping the soil open beyond a depth of 6 inches also exposes vital anaerobic microbes to lethal UV radiation and heat, accelerating the evaporation of trapped moisture. Adopting a strict minimal tillage protocol, disturbing no more than 4 to 6 inches of topsoil, protects these subsurface moisture layers and preserves a safe structural habitat for earthworms. Those earthworms and beneficial bacteria require a stable, uncompacted environment to digest organic matter and convert it into bioavailable nutrients for the cash crop. Preserving the physical architecture of the soil layer is the absolute prerequisite for any biological recovery. Once the physical structure is secure, farmers implement microbial inoculation as an engineered biological replacement for synthetic NPK fertilizers. This cutaway of a 200-liter fermentation drum details the formulation. The slurry combines cow dung and urine, jaggery to serve as a carbon source, pulse flour for nitrogen, and a scoop of native soil to act as the microbial starter. Over a 72-hour aerobic and anaerobic fermentation cycle, the jaggery and flour act as rapid fuel. The native bacterial population multiplies exponentially, creating a dense biological concentrate. Applying this fermented slurry to a field rapidly breaks down dead crop residue, converting it directly into stable, carbon-rich humus. That newly created humus physically restores the soil's porosity.
It holds moisture precisely in the root zone, frequently reducing the need for active irrigation by up to 2 months. By restarting the farm's native, self-sustaining nutrient cycling engine, this microbial inoculation zeroes out fertilizer operating expenses. The next protocol redesigns canopy architecture. Standard, high-density row spacing creates severe resource competition, evident in the dense footprint of a primary cash crop like sugarcane. This architectural blueprint illustrates the alternative. By expanding the distance between rows, shifting from a tight 2.5-foot spacing to a wide 8-foot gap, the system maximizes the photosynthetic efficiency of every single plant. Those 8-foot gaps are not left empty. They are filled with secondary crops like sorghum or papaya, creating a multi-tiered canopy that acts as a living mulch, retaining soil moisture and naturally suppressing weeds. The core financial mechanism is highly specific. The yield from these secondary crops generates an entirely separate income stream, one designed to completely cover the operating expenses of the primary cash crop. This spatial polyculture takes a standard monocrop expense liability and turns it into a self-funding, biodiverse ecosystem. The final protocol replaces toxic eradication. Conventional agriculture blankets fields in broad-spectrum chemicals, indiscriminately killing the entire local ecosystem. Pests do not actually need to be eradicated, they only need to be deterred. Deterrence preserves the populations of beneficial predatory insects that naturally manage pest numbers. This macroscopic view illustrates olfactory disruption. Certain organic compounds emit scent waves that cause incoming pests to immediately reverse course and abort their landing sequences. Farmers formulate these disruptors using highly specific inputs, like 1-year-aged buttermilk acting as a fungicide, or asafoetida mixed with complex botanical alkaloids from neem and tobacco leaves. These compounds repel pests through severe scent and taste disruption, protecting the harvest without leaving lethal chemical residues on the food itself. True pest management relies on establishing ecological balance through deterrence, deliberately avoiding the biological collapse triggered by constant chemical warfare. Seed treatments, minimal tillage, concentrated microbial slurries, and olfactory pest control all feed into a single biological feedback loop, rapidly rebuilding the soil's carbon profile. This micro-level soil restoration directly drives macro-level human health, establishing chemical-free farming as an urgent environmental conservation imperative. By removing synthetic poisons from the water table and producing highly nutrient-dense, toxin-free food, this biological system actively combats modern health crises. True agricultural wealth isn't generated by brute forcing the environment with expensive synthetics. It comes from working in precise tandem with natural biological systems. Abandoning chemical dependency is a highly advanced, mathematically sound evolution of modern agriculture. Thank you for watching the JP Organic Farm. If you found this scientific analysis and research report valuable, please like this video, share it with your friends and fellow farmers, leave your valuable thoughts in the comments, and subscribe to the JP Organic Farm for more scientifically backed content on organic and natural farming. Your support helps us spread reliable scientific agricultural knowledge to more people. Thank you.